Hello friends, this question is from the subjects of analog in the topic of operational amplifier. In the question we have an op-amp which is in the inverting terminal connected to a resistor R1 and R2, and a non-inverting terminal we have a resistor R3. We need to find out the value of R3 such that bias current IB is ignored. Let us assume in the non-inverting terminal we have a bias current IB going from ground to the op-amp. So I can write down my IB as 0 minus V plus by R3. Current always flows from higher potential to lower potential, where V plus is the potential of the non-inverting terminal. It is my V plus. Similarly, in the inverting terminal, the potential is V minus. So now let us assume that there is a current I1 is flowing from V into towards V minus, and current I2 is flowing from V naught output to V minus, and the same current IB which is entering in the non-inverting terminal. We know that in the ideal op amp, my current entering in the non-inverting terminal is equal to the current inverting in the inverting terminal. So in my inverting terminal also IB current is entering inside. So if I can apply the KCL here at V minus, apply KCL at V minus, so my I1 plus I2 is equal to the IB. So my I1 will be current flowing from input, so it is V in minus V minus upon R1, plus I2 is the current coming from V naught to V minus, so is V naught minus V minus upon R2, and IB is a current which has been defined in the non-inverting terminal as minus V plus upon R3, or I can write it down as a IB only. Okay, just leave this term as a IB only, and from this expression of the IB, I can write down the value of V plus as minus IB times R3. Okay, minus. Okay, from the and from because the op amp is ideal, we also know that one more condition of the ideal op amp is that the potential of the non-inverting terminal is equal to the potential of the inverting terminal. So my V plus is equal to V minus. This is one more fact we know. So now let's solve this question number 1. So it will be V in by R1 plus V naught by R2 minus V minus times 1 by R1 plus 1 by R2 is equal to IB. So in place of V minus, if I may put the V plus, or if I may put the value of V plus, which is minus IB R3, because V plus is equal to V minus, so I can put the value of minus IB R3 here, IB R3 here. So this will be V in by R1 plus V naught by R2 minus minus plus, so plus IB R3 times 1 by R1 plus 1 by R2. I can take the value, I can transfer the sum of the term, so my V naught by R2 will be minus V in by R1 plus IB minus IB times R3 of 1 by R1 plus 1 by R2. So I can take the output V naught as minus R2 by R1 and plus R2 times 1 minus R3 1 by R1 plus 1 by R2 times IB. I can further write it down the expression as V naught is equal to the minus R2 by R1 plus R2 minus R2 R3 times 1 by R1 plus 1 by R2 of IB. So in the expression you can see that if you want to ignore the effect of bias current, so you need to make this term as 0, because In the expression of the V naught, my minus R2 by R1 is not minus R2 by R1 don't have any component of IB or bias current, because my bias current has this component. So if I can take my value of R2 as equal to the R2 R3 times, if I can take the LCM R1 plus R2 by R1 R2, so this R2 and this R2 cancel, so I can take the value of R3 as R1 R2 upon R1 plus R2. It means if the value of R3 is R1 R2 upon R1 plus R2, or R1 parallel R2, if I can take the value of R3 as R1 parallel R2, so I can ignore the effect of bias current in the circuit. So if you want to ignore the effect of bias current in the output, you need to take the value of R3 as R1 parallel R2, or R1 R2 upon R1 plus R2. So my correct option is option C. In this question, my correct option is option C. Thank you.